Hi there, my name is Mitskar Lapidis, and in this video, we will work together some first-degree equations, and more precisely, some equations in which we need to apply the distributive property first before we start even solving. Let me remind you, first of all, what the distributive property is all about. The general form of the distributive property is the one I'm now writing. When we have a number, let's call it A, multiplied by a bracket, this is the same as multiplying that number in front of the bracket by each one of the terms inside that, AB plus AC. So, for example, if we have 2 multiplied by x plus 1, the result should be 2 times x, which is 2x, plus 2 times 1, which is 2. Negative 3 multiplied by x minus 1, it should be minus 3 times x, which is negative 3x, followed by the product of minus 3 multiplied by negative 1, which is plus 3. So that is the distribution. In some of the exercises that you will meet when solving first-degree equations, you will need to apply that first before you simplify or before you expand your expressions and before even starting solving the actual equation. So let's work some examples on this direction. 3 multiplied by x plus 5 equals to 2x plus 9. As always, we will follow our approach of visualizing a line that can act as a boundary between the left-hand side and the right-hand side. At first, and that's what makes this video different, at first, we will apply the distributive property at the left. 3 times x is 3x. 3 times 5, it's 15, equals 2x plus 9. Now, we need to separate knowns from the unknowns. By unknowns, I mean all the variable terms, while by knowns, I define all the constant ones. I need all the unknown terms to move at the left. Remember that we can easily move one term from one side to another, since all these terms are being either added or subtracted to something, by changing their signs. So I need to gather all yellow parts at the left. 3x was already there, so nothing will change. 2x, however, it should move from the right to the left, which means that its sign should be different. It should be minus 2x. 15 should move from the left to the right, so it should be minus 15 plus 9. 3x minus 2x is 1x equals negative 6. And there you are. You have your answer. 1x is the same as x. X is negative 6. Let's see another example. Example number 2. Negative 2 times x plus 5 plus 8 equals 6x plus 12. Again, I will begin by visualizing a line that works as a boundary between the two sides, left-hand side and right-hand side. I see that I have a distributive property to apply first, so I'm going to do it. Minus 2 times x, it's negative 2x. Minus 2 times 5, it's negative 10, plus 8 equals 6x plus 12. Now, I'm going to color all the constant terms by blue and all the yellow ones by all the variable parts by yellow. Remember that I should bring all the variable terms on one side. I choose to bring them at the left side, and all the constants to the other side. Every time we change one term from one side to another, we have to change its sign as well. Negative 2x was at the left, it remains at the left, nothing will change. 6x was originally at the right, it should move at the left, so it should gonna be negative 6x. Minus 10 was at the left, it should move at the right, it's gonna be plus 10 minus 8 plus 12. Negative 2x minus 6x is negative 8x. 10 minus 8, it's 2, plus 12, it's 14. And finally, to get rid of the negative 8 and therefore solve for x, I will divide both sides by negative 8. 14 over negative 8. So x is minus 14 over 8, and that would be my answer. Let's finish this video with one case in which we have distributions with two more exercises. Sorry, let's see a double distribution. 5x, let's make it 6x plus 10. So here I will begin, as always, by drawing a line that can serve as a boundary or basically as a reminder on where I should move terms from one side to another. I will firstly begin by applying the distribution in the first case. 3 times x is 3x, 3 times 1 is 3. Then 2 times x is 2x, 2 times negative 1, it's minus 2, equals 6x plus 10. Now I'm gonna color by yellow all variable parts and by blue all the constants. Remember that I should gather all variable parts on one side. It's irrelevant to which side. I choose to bring everything on the left. 3x was already there, it stays as it is. 2x was already there, it stays as it is. 6x should move from the right to the left. It should gonna be negative 6x equals minus 3 because it moved from the left to the right, plus 2 because it also moved from the left to the right, plus 10. So now I need to simplify. 3 plus 2, it's 5x. Minus 6x is minus 1x. Equals minus 3 plus 2, it's minus 1. Plus 10, it's 9. I need to solve for x finally, which means that I should divide both sides by negative 1. So 9 over negative 1. These are cancelled out here. X should be equal to negative 9. And let's see one final example in which I have distributions in both sides. Minus 2x plus 3 equals 3x minus 6 plus 5x. Again, as always, you should all be used to it by now. We will draw a line that can help us separate the left side from the right side. Here, I have some distributions involved, so I will begin by those carefully. Minus 2 times x is negative 2x. Minus 2 times negative 3, it's plus 6. Minus 2 times x is negative 2x. Minus 2 times 3, it's negative 6, equals 3 times x is 3x. 3 times negative 6 is negative 18 plus 5x. Let me color all constants with blue and all variable parts with yellow. My goal is to bring all variable parts at the left, so negative 2x minus 2x. They were already there, so nothing will change. Minus 3x minus 5x is negative 6 plus 6 minus 18. Now we need to simplify. Remember that when we add like terms, we keep, it's like adding similar items. 5 doors plus 10 doors, it's 15 doors, minus 3 doors, it's 12 doors, and so on. So minus 2x, it should be minus 4x. Minus 3x, it should be minus 7x. Minus 5 again, it should be minus 12x. Negative 6 plus 6, it's 0. 0 minus 18, it's minus 18. And now I need to divide both sides by negative 12 so that the x is left by itself. Eventually, it's going to be x equals negative 18 over negative 12 is the same as 18 over 12. And that's all. I really hope that this video helped you solve some of your questions. In case it didn't, and in case you have more things to add, more issues, please don't be shy. Leave them below this video in the comment section, and I will make sure to respond as soon as possible. As always, thank you for watching and thank you for your time.